Welcome to Pratidhwani, where we try to humanize science. I'm your host, GV Pawan Kumar. It is my delight and pleasure to introduce you to my guest on this episode, Susmita Adhikari. Susmita calls herself as an astrophysicist and a cosmologist who is preoccupied with the universe and its inhabitants, which is quite fascinating. Susmita is an assistant professor at the Indian Institute of Science, Education and Research, Pune. And is at the same department I work at, and I'm delighted to have her on this particular episode. To just give you a brief background of Susmita, she did her PhD at the Urbana, Champaign, UIUC, and subsequently she was at the Kavli Institute of Particle Astrophysics in the Stanford University, and subsequently she was also a postdoc at the University of Chicago and Fermilab, and she moved to ICER recently, and I'm so happy that she's joining in. Her specialty is actually dark matter halos, and within this large basket of dark matter halos, whatever comes out of that is what she's interested in looking at. So welcome to Pratidhwani.
Yeah. Thank you, Pawan. Thanks so much for having me. I really like what you're doing, and I love the one-line explanation of humanizing science. I really believe in that.
Yeah. Thank you. So Susmita, tell us a little bit about how you really got interested in science and furthermore astronomy probably and astrophysics. Give us a kind of a picture of how was your upbringing and what was your background in getting into science.
Yeah, so I've thought about this a lot, and I think it's hard to pinpoint a moment when I became interested in science. I think growing up, I grew up in an atmosphere, I think, where I always, in some sense, I always enjoyed rational thinking. I think that is probably my sort of biggest inclination towards science. And I think from the earliest days that I can think of, I think it's probably getting influenced by my father to a large extent growing up, that I think I started thinking of myself as in the future as a scientist when I would, be a professional. My father himself is an engineer, and he was always, and he really loved his craft. Like, he was the old school engineer who did mechanical engineering, but he really loved the aspects, the scientific aspects of what he was doing. So he would always, he would ask me questions of many different kinds, look at observe something and, tell me how it works. For example, how a plane would fly, or when I would take a flight with him or go on the train with him, he would tell me how the tracks would change, why it's designed this way, or why the plane would take off. In fact, even today when I take off in a flight, I think of Bernoulli's principle. I'm a nervous flyer, but I take off of what are the, he would inspire me to think about what are the different principles that go into how things work, essentially, right? And then, I grew up in this atmosphere where him and his friends would discuss these things. And I remember as a child, one of my father's friends, actually, who was in BRC at that time, he asked me, okay, how do you think, people measure the value of pi? I think I was in class 2 or class 3 at that point of time, when they didn't, how did they come up with the fact that, the circumference by diameter is this number? And it was like really fascinating to me, it was like, yeah, really, what would I use to actually measure these things? How would I check that, how would I come to this conclusion that there is this beautiful symmetry in the universe, that, this works for some reason? Or then, I gave him a bunch of answers, and then he would say that, how would you ensure that it's actually a circle? And I'm like, So I think I grew up in this atmosphere of asking questions of things around me, and I think I found it both scientific to approach with numbers and also philosophical in some sense, I think. So I like thinking about things deeper. So I think that way I sort of got interested in doing science. I also enjoyed math. I think a large part of why I ended up doing science was I enjoyed math growing up in school. I think me and my sister were polar opposites in that sense.
What was the place?
Huh?
What was the place?
Where I grew up? Yes. Yeah. So I think so. I was born actually in Bombay. So I spent the first few years of my life in Bombay, and then I moved to Oman for a short time, for 2 years, and then I moved to Calcutta in class 4. So most of my school life has been spent in Calcutta, and then I I was there in Calcutta till I finished my bachelor's before I moved to Bombay again for my master's. Yeah.
Nice. So you mentioned the influence of your father on your thinking, and this is something which is very interesting because I'm curious to know what was the kind of conversations you used to have. Of course, you did mention something related to some puzzle and other things, but could you just elaborate a little bit about a typical dinner table kind of a conversation? Was that very prevalent? Because you also mentioned you have a sibling. So,
So, at my house, I think so I don't know how we'd have a bunch of different conversations all the time. I think it was not always specific to science. My sister actually was, unlike me, actually growing up, she was a lot more into reading and literature and those kinds of things. So we'd have basically, and my father was a science guy. Okay, so they would have actually a lot of debates about, and I found it interesting. So they would have a lot of debates, as to what is the thing that you should study and what is the thing you should not study. So I think
it's elder sibling.
My elder sister. Yeah. So I grew up a lot, trying to think about these questions, but generally, our dinner table conversations were quite wide, and they weren't specific to science, but I think they were enriching in other ways. Like they were simple, usual things about how we view life, but nothing very deep usually. But yeah, that's it.
So one of the important aspects, especially this is kind of a general observation, is that people who tend to go into astrophysics, astronomy, also have a reasonably strong anchoring in mathematics. And you did mention that you had some interest in that. Was this kind of interest developed through school, or was there something you read within your let's say everyday reading, something which motivated you towards mathematics?
No, actually, I would say in my case, it was mostly through what developed in school and what I was learning in school. I think, so in that sense, I was, I think one of the reasons why I went into astrophysics and why I went into sort of, and I was actually very inclined towards more of the theoretical side. So I think one of the things that really, really fascinated me was when I was reading for the first time in around class 8 and 9 about the life cycle of a star, and there I think seeded from something that I learned in school, but then I went in, remember reading up a lot from popular articles essentially of how, many different fields of science come together over there, like of physics come together over there, starting from mechanics to gravitation to, and all the things that I was learning at that, just very introductory stuff at that point of time, just learning mechanics, classical mechanics, gravity and quantum mechanics and thermodynamics. I didn't even probably think of them as very separate things at that point of time, how they come together to explain this really beautiful system. So I think that was a very important, I think that those kind of things of bringing these things together, and I think got me interested both in the theoretical aspects of astrophysics and also just taking that on as something I would do in the future essentially. Yeah.
Very interesting.
Yeah.
Because astrophysics is probably, at least in my opinion, one of the highest forms of applied physics.
Yeah.
Because
it is actually very,
as you clearly mentioned, you need to really explore all sub-disciplines of physics, bring them to the table, so to speak, and then utilize them to explain and other things. This also means that you probably would have also had reasonably good education at schooling. Would you want to tell a little bit more about your schooling?
Yeah, I think I was. So I think there are both aspects. Firstly, I think to be I grew up in I went to a fairly privileged school. Okay, so I think I acknowledge that. And we had exposure to good teachers, good materials and stuff. But I think a lot of, there's two aspects to it, what we learn from school and how much time we spend on it. And so I think both of those things came together. In my case, like reading deeply into what I was, reading deeply into what I was studying at that time is something that I was sort of inculcating in myself while also being a part of the larger school culture, But so there's one thing in, one of the things that has really actually influenced me more than schooling, I would say, is moving to Calcutta was a very important life change for me. I think growing up there has influenced me in many ways. And I don't just say it as, I spent a lot of my time growing up in Bombay and then in Oman, and then I moved to Calcutta. So I spent the first part of my life being exposed to many different cultures. And I think I really appreciated that exposure. And then I moved to Calcutta, and I think the way people approach studying and just knowledge over there was a very big influence for me. I think, just valuing knowledge, valuing reading, value the things that people value over there, valuing language, are all things that I can't really pinpoint as this happening at this point of time or that happening at that point of time. Whereas I think it was a very wholesome place to grow up in, culturally, not just in science, even culturally through arts and everything else. The kind of influence that it brings on you to value things deeply and value the meaning of things was something that was inculcated in studying in a school and a college, I think, in Calcutta. That was a very strong influence on me.
Absolutely, absolutely. In fact, that is probably one of the most important aspect because the location at which you are growing up has a huge implication on what you become. Yeah. Second point is that you also at a very early stage seem to have been exposed to various different cultures.
Yeah.
Which also is something very important.
Yeah.
And many a times it's not usual for somebody to get exposed as early as what you had. So was that also an important influence in you kind of, growing up and looking at the world in slightly different way?
Yes, absolutely. I think exposure is really so important to all our lives, and I cannot value it enough. So looking at how different people live their lives and how different people perceive and interact with their day-to-day life is really, really important. And it's very easy to become narrow-minded in your own world and think that this is correct and this is wrong and hold strong biases. But I think for me it was really nice being able to grow up in Bombay around, different kinds of people, trying to learn to speak Marathi, trying to inculcate their cultures in food and music and dance, and just the small habits that people have in their day-to-day life, and just appreciating them, and then when you look back and try to compare it, you feel like you understand them at some level. Of course, living a life is different, but you still understand that at some level, and you become more open to new ideas. So I think I think in that sense, I really enjoyed growing up, spending a part. I value that part of my younger life, which I spent elsewhere also very, very much. And that's a theme that has been true in my life generally, and I'm sure a lot of scientists' lives, because I think we think of ourselves as thinkers and stuff, but a lot of it is really comes from the exposure that we get in life, right? Like the different kinds of people we meet, the different kinds of science that we do, and all of that. Yeah.
Absolutely. So you mentioned languages. So you can speak Marathi?
No, I can't speak Marathi. I can understand Marathi now, nice. But I want to learn Marathi.
Same here. We're all in the process to speak. Yeah. So now that you've got a good foundation, thanks to, of course, the place and also the schooling at which you were brought up. This also means that you are now you are setting up yourself to a kind of a career which is slightly more intellectual. Given that you already have a good ecosystem at home and you have a sibling who also probably would be interested in doing something. So what were the kind of choices you were exposed to, or what are the choices you had to make at very crucial junctions? Because see, as early as your high school, you're already trying to think about what is the kind of things you're interested in. Because that is probably the first place where you get exposed to slightly more broader context.
Yeah.
And also a lot of pressure, so to speak. So could you tell us a little bit more about that phase where you're trying to kind of make your way through the observable world, so to speak?
Yeah, so there are many stages, I think, you come up with this question. First is, of course, from the first transition where you have to make a choice between which direction that you want to go to. I was quite sure that I wanted to do science. But then I think, as is common in a lot of Indian families, our parents want us to be engineers and doctors. I think I disappointed probably my family to some extent. I was always sure that I wanted to go into one of the purer sciences. Again, I think that is influenced by a little bit growing up where I was growing up, just because one of
anybody who is in Kolkata cannot escape the fever of basic sciences.
Basic sciences, basic arts,
basic arts,
it's both. Yeah, it's one of those places where it's really appreciated. Like the topper in my school essentially went into humanities, and it's really respected, and men do a lot of humanities.
Absolutely.
And they're encouraged to do so. It's not just that they do so.
Absolutely. In fact, that is something which is remarkably different. I don't know whether it's still prevalent, even within Kolkata's intellectual culture and ecosystem. But I have seen some really good people who are interested in doing something a little bit more open-ended, did not confine themselves only to sciences or technology, so to speak. And we can see how important it is nowadays, right?
Yes, absolutely. Yeah. So I was always sure that I wanted to do the pure sciences. So I was, and also I think I did not want to spend, I was doing a lot of things in my 11 and 12s. I was also very interested in extracurriculars growing up, actually. I love dancing. So I was also spending a lot of time doing a lot of extracurriculars at that point. And I did not want to spend.
What genre?
So I did Bharatanatyam very young, and then in my school, so I did a lot of other forms of dancing. So creative dancing, Rabindra Nitya, Odissi from my friends, and so on. But I really, really love Odissi, and I think I have on and off again learned Odissi, and now I've joined a class here.
Wow, nice, very nice.
So I think
Pune is probably a great place.
Pune is a great place to pursue all of these things. It's a bit, it's a little complicated because of the distances I might have to travel, but
But you still have something which is there in the city too.
Yes. There are many options. The one that I'm going to is a bit far, but there are good options both in creative dancing, and I'm also interested in Western styles as well, and in Odissi.
We'll come to that. Because that is an important point. Because listeners who are actually paying attention, a scientist is not somebody who is just going to sit in front of a computer or in a laboratory. Absolutely. They have multifaceted approaches to life, and this is an example, and we will surely discuss at some point of time. So now
so I think sorry, you were saying something.
Please go
ahead. Just going back. So that was one point at which I had to make this decision of what I wanted to go. And the other was after my master's in IIT, if I wanted to stay back here or go abroad and pursue a PhD in science. So again, I think at that point of time, I was also growing up, so a lot more complications of society, of being a woman, and all of those things come up, and why you want to make this choice, and why do you want to leave home and go somewhere else and do this? What will you gain from it? And Isn't it safer to be here? Isn't it? And many different things, even being from a simple middle class family, is this something that you should pursue? So that was again another strong, another place where I think that was a place where I had to do a lot of explaining to both my mother and my father to really justify why I wanted to make that choice. And it was not easy. So I hope eventually they are happy as I am.
Obviously.
As well. And then of course later the choice of working in India was not a difficult choice. I think it was something that I had always thought I will do.
We'll come to that point because we'll go transitions by transition because that is a very important thing, because that's where a lot of things also become clear in how one is trying to approach one's life through science. That is an important thing. A lot of people also have to make such decisions, and it is also a great learning process for everybody. It need not be only younger people. So one of the aspects is that transition from the high school to the college, probably one of the biggest cultural transitions also one has to make. So I assume that you are still in Kolkata during that transition?
Yes.
And where did you go to schooling and also the college? Could you tell us?
So I went to school in Ashok Hall, high secondary girls' school. So Calcutta has this weird thing of having girls' school and boys' school. And then I went to college in St. Xavier's College, Kolkata, and did a physics honors there. Yeah.
That's a very well-known college.
That's a very well-known college, yeah.
So during that phase of your undergraduate studies, which is surely one of the foundational kind of educational kind of platforms you will have to go through in order to launch yourself into anything what you want to do going forward. What was the kind of system you encountered? What kind of physics, for example, what you learned? Could you tell us?
Yeah, that's actually that was a very as far as physics is concerned, that was a very important stage in my life. Firstly, I think more than my school, in my college, I was exposed to some really, really good teachers whose teaching and the thing that I learned from them, I still fall back upon oftentimes. So one of our professors was Professor Ananda Dashgupta, actually I should mention by name, and he used to teach us mathematical methods, and he was a wonderful teacher. He would come in with one problem in class and explain, various aspects of it. Just take that one problem and just, tell us how to do it in many different ways, and what are the different things that we learn from doing it in different ways. And, he was this very casual person who did not care about attendance or anything, but still, some of us would be there every single day because it was just such a good way, such a rich experience, right? And so that is something that I really, really remember from college. Also, being exposed for the first time to really good experimental facilities. Like we had a really good optics lab in St. Xavier's College, and a really good electronics lab as well. And I was not good with my hands. I think I'm not a good experimentalist, but I really, really that was the first time I was exposed to these things, and I think I really, really appreciated that. And the other thing that I think that was really good for me in Calcutta University, which worked well for me, and we all have we have some broad different ways of learning amongst people, and I think one thing that was really good was the amount of leeway we had in sort of, in a sense, teaching ourselves, because we had, it was a bit of a challenging system because we had this part 1, part 2, part 3 system, and part 2 was cumulative of 1 and 2 and everything. But they had this very, it's an odd thing to remember, but they had this very weird thing where we would get like a 3-month holiday or 2 to 3 month holiday before our exams, right? And then you would really, and you were not doing it for your, it was really you and your books, okay? So you spent on your own a lot of time with a lot of free time, actually. And I think that is so important in any kind of learning, particularly in physics, where you sat down with your stuff and explained, drew things that you learned in class and really went through all of the literature in your classes, right? And I think that was really, really valuable to me. I never felt cramped. I enjoyed studying, even if it was for an exam which was really had a bad policy of math suppression, so it's a messed up system. But I think that gave me a lot of confidence in myself, and it gave me a lot of it really started making me enjoy physics, different aspects of the subject that I was really studying.
Very nice, very nice. So it means that you probably would still be exposed to all branches of physics, sub branches, and generally this is a great education for astrophysics, right? I'm trying to figure out how you're developing into an astrophysics person. Are you already thinking about astro then, or?
So astrophysics was always at the back of my mind, because I, even though you don't study astrophysics in India so far, we don't really have astrophysics as a subject. In very few places actually have it. Even during my masters, we didn't have it. But you are always drawing examples from astrophysics in many different systems that you study throughout. From learning about gravity, and understand, of course, GR is really, really important.
GR for listeners is general
relativity. Yes. So in that sense, it was, if I wanted to specialize in something, I think I always knew that I wanted to specialize in astrophysics. Just from the diversity of, even though we were not learning it specifically, I was really interested in astrophysical systems. So in that sense, I knew that if I wanted to specialize, I would do that eventually. Later, when I went into my masters, when I started studying general relativity, and I also worked in my master's project on a project that was not related to astrophysics. Actually, it was sort of, or it is in some sense. There's no sharp line that way. So it was related to black hole holography and all of that. So I think I always I was very interested in astrophysical systems, and that might be something which is, it's a bit of a cliche, because as a physicist you grow up and astrophysics is very visual, and so it's easy to get influenced in that way. So even now when my students
guilty as charged.
Yes, absolutely. So I think I always knew I wanted to do that. Yes.
So then you were also making a transition from bachelor's to master's. You continue in the same place, or you go elsewhere?
No, I went to IIT Bombay for my master's. Okay. Yeah. So so I was in IIT Bombay for my master's. So I think both, again, science-wise and also life-wise, both of these were really nice places, because once I went to college, my perimeter of the people I meet increased from all parts of West Bengal, and many different, types of people again come together. And similarly, when you move to Bombay, it was a really nice experience to share that life with people from all parts of the country.
You were already familiar with Bombay in that sense, right?
I was. I mean, I was there at a very different stage of my life. Yeah. And then growing up, I felt at home because it was Bombay. But IITs are these places which brings together people from all parts of the country, right? And that is really, really nice. Parts from all the different states and all different kinds of people. So that way, it's a multicultural place in that sense. So
Absolutely.
I really enjoyed my time at IIT as well. It was a different system of education. It was more towards the semester system of education and doing projects. And the IIT system is where you start focus. Unlike the Calcutta University system, the IIT system was more where you start focusing on problem solving, and that was a very different way of approaching science. I thought than what I was partly trained to do, but there it was where the rigor really came in, because you were faced with a lot of time problems that you had not prepared for, or you have to bring in your thinking at that point of time to solve them. So IIT semester system was also a good training for me in some sense. Yeah.
Fascinating. So these times are also the ones where you would probably be also looking at serious career questions, right? Because those are the points where you will have to make a decision on almost what you really want to do for, let's say, next 10 years, 15 years, or even long-termish stuff. So IIT is a great place, and especially if you are in an ecosystem where research and other kind of things are encouraged, you would know what are the avenues available.
Yeah.
So what was going through your mind then? Like, who were the people whom you're talking to? What kind of discussions were you having? For example, your own peers. What is the kind of exposure you had during that particular time? Could you please tell?
Yeah. So in that sense, I think being in the IITs is when I seriously started considering going for a PhD. And while I knew that I always knew that I enjoyed doing this. So actually, probably going back a little bit, I always thought of myself as a teacher growing up, like either a professor or being in the teaching profession, rather than being, I really thought of myself as a professor all the time, because I really enjoyed physics. I really enjoyed, I enjoyed learning and working on that thing a lot. And I think at the IITs, when I was first exposed to research, and because of the peer exposure that you get over there from your seniors and from historically how IITs have had students going into, particularly in physics, going into PhDs, I think that's when I first started considering to take research as my profession. The primary goal of my profession to be research. So in that way, again, IIT is a very privileged place in that sense, because you have contacts, you have professors who can guide you to how to go about it, and that is really important. I don't know a lot of people are, and now today we should think about how to expand that exposure to more people. What are the different options available for me, whether I want to stay in the country, whether I want to go abroad, there's a lot of advice that you get from my own master's thesis advisor was Professor Ramadevi, who was working at that point of time, and she and many other professors at that point of time encouraged us to apply widely, and mostly I think it was being in that moment at that place at that time. It made sense. And also just life-wise, taking a step to going somewhere else was
absolutely.
Yeah.
Absolutely. So at that junction, you're also thinking about US already, or
I was thinking about US, but that was mostly because of peers. That's clear as it was. Yeah.
So tell us about that transition, because that's also another very big leap.
Yeah.
What was the process? What was the kind of decisions you had to make? What was the questions you were asking yourself in making such decisions?
Yeah, so that was I think moving to the US was probably in my life, I think one of the most important life transitions that happened to me. And I learned, because it was a stage of my life where I was, absorbing things a lot faster. I think you're growing up and you're starting to live on your own for the first time and taking independent decisions for the first time. I think it was a very enriching experience to me to get exposed to the world of science and how science is done, right? There's one aspect of learning science and teaching science and absorbing science. And then there is another aspect of doing research in science and how to take knowledge forward, right? And how that is that is such a human endeavor and a social endeavor, and is something that I really learned in the US, both work culture wise and both how to become an independent scientist, really, right? I think that was I did my PhD at the University of Illinois, Urbana, Champaign, in the astronomy department. And the most exciting thing for me, I think, over there was, PhD can be challenging. It was nice for me in some sense because both my partner, Orko, and me, we were both there at the same place. So it was easier for me in many ways, but otherwise, for a lot of people, because it's such a new experience, something that you are not trained to do, and you're really learning to, for the first time, understand how to do research and how much of what that involves, and learning to fail at different steps, and how to go ahead. So it can be quite an interesting experience, and it's very different from studying physics or science, right? So I think it was. I really enjoyed my time over there. The first aspect that I really enjoyed over there was the being at the forefront of scientific research, right? The amount of exposure that you get to what is happening today in science. What are the questions that people are looking at right now? How are they trying to solve it? That weekly, not just weekly journal clubs, weekly talks, and how important that is. How sharing ideas and discussing science is so important. Just to sharpen the questions that you are working on. How talking to people is so important, and I think that atmosphere was really enjoyable. I think it was really enriching, actually, and I think we are always seeking that atmosphere as scientists, to feel constantly challenged, and to try to resolve that challenge in some sense, right? And I think that was a really enriching time for me. Yeah.
Fabulous. UIUC also is one of the most famous schools for physics, condensed matter physics, especially.
Yes.
People like Bardi and others have really, have their imprint on that particular place. So how was the ecosystem while doing your coursework, learning new things?
Yeah.
And given the fact that you are also in Urbana, Champaign, which is in the Midwest, close to Chicago, probably that's the pathway you would generally take. Given the fact that I also have spent some time in my life a long time ago in the Midwest, it has its own interesting charm of, slightly more offbeat than conventional coasts of the US.
University town.
Yeah. Could you just paint us a picture about that place?
Yeah, it's as a PhD student, it was a really nice place. So it's sort of, it's called the university town, as just more for the wider audience. It's most of the town and the things that people do over there are centered around the university. Most of the things are connected to the university. There are a few other industries and stuff over there. So it had 40,000 students at that point of time.
And a large Indian.
And yes, a lot of people called it the University of Indian and Chinese people. So yeah, it has a large international student component, both at the undergrad and at the PhD level. And and it was very nice. It's a vibrant place for students. A lot of things are going on. It's got, even though it's a small town, it's got fairly good public transport, actually, which is really important.
Very surprising, right?
Yes, very surprising in the US, and very important for me, having spent a lot of time in Calcutta and Bombay. So it was nice. It was a very vibrant place, both academically and just culturally. Very, very nice place. So and the physics department, and is very famous there. And it was really nice because we were students over there. The university was invested in us, and we were part of its academic, intellectual environment. And it was so nice because at that point of time, one of the things that I remember, and this is just a sort of it's a positive culture shock, as you would call it. One of the things that I remember was, Anthony Leggett, who was a Nobel laureate, was there at the time in the physics department, and he used to basically, come to work every day. You would see him around the university all the time in his red jacket, walking around. He used to take a class on philosophy of science at that point of time. And I remember, in one of our astro department colloquiums, it was very full, and I can't quite remember who was giving the colloquium at that point of time, but the room was really full. And I think it was just after the the Planck satellites announcement that they had measured the scalar to tensor ratio, sorry, jargon. But so it was an exciting time. And I think he came in for the talk, and the room was completely full. And I remember he just walked in and sat on the floor, and was listening to the talk. And it was so, it's a strange thing. It's a culture shock, as I said, but it's a positive culture shock of how egalitarian science has the potential to be, and how it has the potential to be. It's not that it is always, but I think it was a really good atmosphere. Just being in that environment of people really. The main thing was the science over there, right? Like the focus of everybody's life was the
absolutely
science.
Fantastic. Yeah. This is actually a great story, because that is probably one of the elements of impressions.
Mm-hmm.
For example, as somebody who is really trying to explore the world through science, and you see somebody who has done it in a very successful way. Mm-hmm. Success is also subjective, but a person like Anthony Leggett is every physics department would be knowing liquid helium, etc. And somebody who comes to the seminar and he sits on the floor, it's a great impression. But that is something which is the strength of American education.
Yes.
Although I've spent only as a postdoc in US, but I also see that the kind of openness you have in an academic system.
Yeah.
Of course, it has come under huge criticism nowadays for various other reasons. Mm-hmm. But at least in conventional science and technology based departments, and to a large extent even in some other departments where the focus is slightly more on broader questions related to natural sciences, that culture is very strong.
Yeah.
And most of the places, irrespective of where they are within the geography of US, you would observe this very, very interesting stuff.
Yeah.
It's kind of almost a melting pot, right?
Yes, absolutely.
So were you also exposed to other things other than the astrophysics there? Because the department, as I mentioned, is already very reputed for physics and even biophysics for that matter.
Yeah. So in fact, I think so. We had the colloquiums, for example, the physics colloquiums were general, right? So we were always we were a part of that all the time, right? So we would essentially, learn about all the different areas, all the different questions that were at the forefront of science at that point of time, including in condensed matter physics, including in superconductivity and your biophysics at the time. So it was even though primarily I was in the gravity astrophysics group, you were encouraged to take different courses, and you were they were also being offered. The PhD curriculum was also very free. I could not completely take advantage of it because having done a physics degree up to my MSc, I had to do a lot of introductory astro courses going in. But typically you had the opportunity to take emergent field theory from Nigel Gondelfeld and classes from Fradkin to everybody. So it was a very open environment in that.
Nice.
Yeah.
Nice. So could you also tell us about the kind of research problems you were thinking about then?
Yes.
What is the kind of questions you were interested in? What is the kind of interesting problems you are getting exposed during that time?
Yeah, so at that point of time, right. So my first sort of, my first question that I started working on with my PhD advisor, Neil Dalal. So we started working on understanding halo collapse essentially. Okay, so we started. I started working on. So there's this. I should go ahead and describe the problem.
Yeah, please.
Right?
Yeah.
So essentially, dark matter halos, which are, we now think we have evidence that there needs to be something like dark matter in the universe to explain the way galaxies move and the way matter distributes itself in the universe.
So it is called dark, just for the listeners, because it is not within the purview of the observable electromagnetic radiation.
Yes.
So therefore, it goes undetected.
Yeah.
But it has been detected using some other indirect methods.
Yes, exactly. So we infer its presence through indirect methods, through essentially its gravitational influence. Primarily, initially, of course, through how things move inside around a galaxy. How stars in the outskirts of a galaxy or gas in the outskirts of a galaxy, how its motion. Its motion depends on the mass within its radius. So that was how it was sort of initially inferred. But now at this point of time, we have multiple evidence from very different avenues that we really need something like a component of matter which we cannot yet detect its electromagnetic interaction, but we really needed to explain, for example, the cosmic microwave background and many other things, the flatness of galaxy disks and so on. So many different avenues. So right. So so what I was working on was essentially, so it turns out when you sort of work with n-body simulations of dark matter halos, where you're evolving a system of dark matter simulation particles in a gravitational field, you form these structures. So halos are bound structures around our galaxy has its own halo. It's a bound, much larger scale, puffier structure surrounding a galaxy, for example. So we were trying to understand the internal structures of these halos, and the problem that I was working in is specifically people see that in these n-body simulations, the dark matter halos turn out to be something which is known as turn out to have a mass distribution that has a very nearly universal mass distribution as a function of radius, called the Navarro-Franken-White profile. But we don't completely understand why that profile emerges. So there are many different ways of approaching it. One of the ways is to understand it through self-similar gravitational collapse of initial density perturbations in the initial universe. So you have a region where you have a lot of dark matter density, and that will naturally collapse under the gravitational influence in an expanding universe and form its internal structure. So I was working on these self-similar models to explain that internal structure. So that was the first problem I was working on. That was purely sort of semi-analytical and using numerical simulation, using some semi-analytical work, so pen and paper and quite a bit of computational work.
So were you already kind of trained in computational physics, or you had to pick up something after you go?
I was, during my college, and even so I was trained in, I knew C essentially, C and a little bit of Fortran, what you learn in a regular college course. So that way I was, I also enjoyed coding quite a bit. So I had some training, but as is true for anything, you pick up as you go, right? So yeah, it was a lot of intense coding that I was doing at that point of time. And also for the first time, I was working on converting actual physical problems into code, which was super fun experience for me. I really enjoy it.
It's one of the most creative aspects also, right?
Yeah.
True.
It's creative aspects, and interestingly, it also makes you really understand the you really have to understand the physics to actually get the code to work. So it really nails you in that sense. You have to break it all apart to put it all together again in some sense. So I really enjoy coding a lot.
Wonderful.
So that was mostly semi-analytical and programming work. But at that point of time, I was working with my advisor primarily, and we can talk about that at some point of time. But one of the things that he would do is he would take his group out to University of Chicago once in a month or once in 2 months, and we would have a group meeting over there with another group, which was Andrei Kravtsov and Nick Ganedin's group over there. So that was a very good experience, and one of the nicest things that happened, and it's part of this talking and talking to people thing. In one of those group meetings, one of Andrei's students were presenting about this new thing that they were seeing in simulations, essentially, where the dark matter distribution, as is understood in the inner parts of the halo, is very close to this universal profile that I was talking about. But they were seeing some deviations in the outer regions of the halo, essentially. And we were just looking at figures and trying to figure out like what's going on. And then essentially, in that conversation, we realized that what they were seeing was very related to some of the one of the things that we were studying using the self-similar solutions. It's called a density caustic, like a small region where the density becomes really, really sharp. And so then we went in and sort of started to investigate what that could be and really try to understand it from the problem that we were working on. And essentially, we worked on that and sort of understood the origin of what that deviation was. And that actually turned out to be one of my most well-read papers.
Nice.
Sort of something that is partly associated to me. It's called the splashback radius. So, and that was a very enriching experience for me, which came out of, that was the first time, of course, in subsequent career that has happened more often, and that is now maybe a way of life also. But I think that was really nice, this exchange of ideas of where you go and, then we worked on this problem, which came out of many different things that people were working on, and it culminated to a real understanding of something new. Was really nice. So that was one of the first few problems I was working on, and I think after that, the other thing that was really, really exciting for me is, so I was doing a completely theoretical thing, right? So theory and simulations mostly. By the end of my sort of PhD, so that's really powerful and exciting about cosmology and astrophysics is that you have data, right? So by the end of my PhD, there were a few other groups who actually went out and measured this feature that we were predicting should exist in simulations. And I think that was one of the most enriching experiences for me, to be able to start working with observations. So I had been sort of detached from experiments and observations for a while. But I think one of the most gratifying experiences is to be involved with the observations, be involved with that experimental aspect of measuring what it is that you're predicting. And since then, I've never looked back. Like, I work very closely with observers. I work very closely with data analysis, and I'm, I have done a little bit of it myself, and I really, really enjoy that aspect of working in cosmology. So yeah, so that's
wonderful, wonderful. Very, very nicely also, elaborated, and you could see that there are at least three different questions you are working on. And it is also a time where you are probably also becoming quasi-independent almost.
Yes.
You also were mentioning about your advisor. Would you want to talk a little bit?
Yeah, I think I think it was a really good experience working with him. As you know, so again, so we've spoken about this a lot with our peers and everything. PhDs can be very complicated because it's really it depends on your relationship with your advisor. Okay, and I think and every person has a unique relationship, and it can become very toxic, or it can become it can become good, or it can be somewhere in between. But I think I learned a lot from him, and I think one of the things that I really learned and became comfortable with working with him is to challenge ideas and be confident about challenging ideas. And being a woman in physics is a very different, is a fairly complicated experience. We can talk more about that. But I think in that sense, he was not, even though we never said it in those words, but he was never hesitant to challenge me, and I gained the confidence of being open and being ready to be myself wherever I was, because I had that exchange with him, because of that value that I gained while being a student as well. And I hope I can inculcate. It was not easy. He's a challenging person himself. Like, he can become he's a nice person, but he can be tricky. But I think I hope I can inculcate some of those things, and remember some of those things when I be an advisor to a student just starting with it.
Very nice, very nice. You did mention about a very important point, which is the woman in physics.
Mm-hmm.
This is a question which is very pertinent nowadays in Indian science community.
Yeah.
In fact, in a larger context, even Indian academic kind of circles, where the presence of women, especially in natural sciences, is not that good.
Yeah.
Biology is better, but physics and chemistry are not that great.
Mm-hmm.
And this is a matter of great concern. There's also something called as Hyderabad Charter. Probably you would be also aware of that, where some of our women scientists, physicists, who have put together some very important information.
Yes.
And they give glaring, data which shows that the participation of women, especially at the higher levels of, let's say, a department or a faculty kind of recruitment, is still not as much as, let's say, even a biology department. You are now in a situation where you have gone through that process, and you have become now an assistant professor, your own individual and independent kind of a group. What are the things which you came across, Susmita, when you were trying to kind of navigate through this system, having also been educated in India in the beginning up to the master level, then going to US, which actually is slightly better, but still there is a lot of issues there too. Before we shift to your Stanford stint, I would want to just ask you, because this PhD is also a crucial time where a woman physicist actually has to really navigate, which sometimes is not obvious to everybody who is aware of the conventional research situation. Could you please tell us a little bit about that?
Yeah, I think that's really important aspect actually. So growing up, of course, I grew up in India, so society as a whole always reminds you that you're a woman. I was lucky in a sense that in my house it became, in the choices that I made with science, was easier for me. I did not have to, it was okay for me. But later, when I had to make life choices, those things came up even from my own family. My mother, though, I should say, is a huge inspiration for me. She always let me be who I was. And I think that has been a very important aspect of my life. But I think the older I grew, the more conscious I became of what it is to be a woman in science, and it's perceived by society as not being a natural place for you. People are not always doing it intentionally, but it reminds you that you are somehow not expect to be here, and it's not clear why. Like, for example, I still remember this, in my physics undergraduate class, someone who is now a really, really good friend of mine said that, you're good at math. You're almost as good as a guy. It's just
Wow.
something And it's so weird because it's just like, what do you, and this person's mother is a master's in math, right? And he would changed a lot. Person has changed a lot since then. But these are the sort of things which are casually thrown around, right? And even though you don't always feel, it's easy to think of yourself as somehow surfacing out of all this, but it's not that. It's like constantly people try to adjust to it. People try to adjust their behavior to it in many ways, and it's just not something that the other half of the society is having to do at that level. That's the difference. But I think as you grow older, you realize, I was one of 4 girls in my master's class. One of
4 out of
40.
Wow.
And that's common.
That's very
physics,
common,
right? Yeah. Particularly, I would say in the institutes which have some kind of competitive entrance or something, it becomes even more common actually. Similar numbers in Xavier's as well. Astrophysics actually does better.
Yeah, you're right.
So it's still skewed, but it's better.
Yeah,
than
among
the
the
rest of
physics
physics,
sub-branches, astronomy and astrophysics has. That's probably because the number of people who really are excited to do astrophysics is so large. Also, the pool probably is much bigger.
Yes. And then so PhD, the number wise, it was okay, but you already start picking up in the power dynamics of the room, on the people who are sitting at the table, amongst your professors. There's like a huge skew in the numbers, right? Like, even in America, right? And then I started my postdoc at Stanford. The postdoc numbers were fairly good amongst the postdocs, but then I went to my first conference, which was this cosmic microwave background conference at Stanford, and it was a room of nearly 100 people, I think, and I think I was among the 4 or 5 women in that room. And then it suddenly hits you, like, it's like the higher you're going, the numbers are shrinking, and the higher you're going, that's where all the decisions are being made, right? And you just start seeing the huge skewed the messaging is all wrong, right? And the thing is that it's, people will argue in many different ways that people just choose to do something else, and why do we need to make room for others when there's hundreds of kinds of things that people will say. But of course you realize that it just becomes harder the fewer, as the number shrinks, you just become othered more easily. It happens unconsciously, but a lot of time, I mean, people will claim that it happens unconsciously, but it just becomes, where the decisions are being taken, it's just such a large lack of women is just, it's stark and it's disturbing, right? And they bring so much to the table. My postdoc mentor advisor, so it was an independent postdoc position, but I was working in this group, at Stanford, Risa Wexler, and she was at that time the director of the Kavli Institute there. And having her at that position makes such a huge difference to the atmosphere in the department, I think. Actually, while I was there, it was a transition. Both the people were great, but I just think that the amount of effort she put to bring to fore, how important this aspect of science is, to have more women, to understand, to hear them, to give them the space to voice any issues that they may be having, is so important. Like we used to have this. So the thing is, in America, the numbers are really bad as well.
Yeah, actually, in fact, probably as worse as as bad as
bad. And apparently they've been getting worse over the last decade or so, which is quite shocking.
Yeah.
Then there's another aspect of in America is black women, if you look at black women, the
Mm.
number of faculty or the number of people in high positions is just even worse,
right? Yeah.
And right, so but it can make a huge difference, and I think so this is why I really like, coming back to the name of your podcast, like human, or the one-line explainer, humanizing science. We often think of science as not being, or we try to think of science as not being a social endeavor, but it is
Absolutely.
like deeply social, right? Even ideas sometimes can take a direction because there are some powerful people speaking about it, right? And
Absolutely.
for ages and ages, a set wisdom will not change because of who's saying that, right? And
so correct.
As much as we think of it as not being, or try to say that, we don't want to get ourselves involved in these human questions, it is deeply human.
Yes.
So it's really important to keep that in mind. So I think there I think the good thing is there is a lot of discussion on this, whether or not a lot of things actually happen, as is true about America. It can be, a lot of things can ultimately end up becoming superficial, but there is a lot of discussion on this. So I read a lot and learned a lot about this. So we used to have these like bi-weekly equity diversity reading clubs where we would just read exclusively on.
This was in Stanford?
This was at Stanford.
Very
yes.
nice.
Where we would read about many different things, just
Wonderful.
Women in science, and a lot about how the experience of Black students in academia, and a lot of that discussion and the importance of that discussion became really, really important. And right, so that is important. And I think then coming back to India, I think now there is a lot of conversation about this, and
yes.
I think that's great.
That's really great.
Yeah.
But still not far away from where we are supposed to be.
Far away, but I think that consciousness is important.
Is important. Yeah.
And consciousness is important, and having a lot of good balance of young and old people to bring new ideas is really, really important, I think. Yeah. So I think there's a long way to go, but at least the conversation is there. Yes. Yeah.
Fabulous. So now we'll make a transition where you will talk about one of the biggest transitions, where you probably would spend some time in Stanford and even a little bit time in Fermilab, Chicago, and then you move back to India. So we'll just go in small steps, so that we would quickly cover this point. What motivated you to go to Stanford and then to Chicago and Fermilab, and then we'll come to the crucial transition here.
Yeah, so I went to so I moved to Stanford in 2017. At that point of time, I was looking for postdocs, and there was a really good group over there who was working. Who was there were several groups. One was Risa Wexler's group, and another was Tom Maple's group, who were working on different aspects of structure formation and their connection to galaxies in observations with the. So I was, and I was also at that point of time sort of starting to work with data and people from the Dark Energy Survey. So it was a natural. So when I got the offer, it was a natural choice for me. And the other reason was, of course, both me and my partner Orko, both of us got an offer from there. So we should mention, because Orko's name, we have brought it up. Orko is also an assistant professor at our department, our colleague, and he's also an excellent research scientist. I'm very sure we will have it at some point of time on Pratidhwani, and they also make wonderful kind of important contributions to the department in terms of the various different areas which we are interested in. Yeah, sorry for the pause, but please go ahead. So there were two aspects. One is, of course, purely science motivated, and then there's life motivated, of course. And I remember going to talk to Tom Abel at that time, who was, making us the offer, and he was like, you can do a lot of things, you can go here, there, but life happens, and you just want to be at the same place. That's important. So we moved there, and of course it's a very good place. So I moved there in 2017. While I was there, I started working with a lot more, many more directions in data as well. A lot of started started working on understanding the connection between how galaxies evolve in dark matter halos, and and also many other different things that I wanted to test with dark energy surveys data, and also would also work very closely at that time with my collaborator in UPenn, who was Bhuvnesh, and who's also been a very important academic influence for me. So, right. So at that point of time, I was, so that's also where I started, experimenting with new things at Stanford. It was an independent position, so it was scary as well as exciting. Yeah. So. No one was asking you whether you've done your work, and you sort of have to do it yourself, right? You already started doing that in your PhD, but yeah, and it was a lot of fun. I started working with students quite extensively, fantastic students over there, and other postdocs, collaborating with my office mates and stuff. So that was a very good experience at Stanford, yeah. And and then also met some of my long-term mentors, and Risa and Tom. So that was who I still talk to today if I need any advice from science to life. And I should say that that's another valuable thing that you get as a researcher. All these nice mentors.
Absolutely, fantastic. And the Fermilab, Chicago.
So it was primarily a position in U Chicago. Yeah. So it was sort of at the end of Stanford. Sort of also. The pandemic had kicked in at that point of time, and was in a dilemma if I really wanted to move from Stanford at that point of time. But I was advised that it's good to have some, again, exposure to different kinds of places and people as well. So then I moved to U Chicago for a year-ish. Primarily, it was a joint position between U Chicago and Fermilab. But that was a really nice time because it was sort of not at the end, but things were just starting to open up, and you really missed interacting with people one-on-one during the pandemic. So all the postdocs decided that they will go to office. So we all used to go to U Chicago at that point of time, wearing masks. There was 1 week in between which we did without masks, but just after that week it was back. But U Chicago, so I was working a lot on at that point of time, something that I started at Stanford and started working on more in U Chicago was the connection between gravitational wave sources and dark matter halos and stuff. So connection between those things, which I'm also working on now.
Yeah. Nice.
So that I delved into more over there. And also, Chicago is an interesting place socially, so it was a really good experience. So I was also part of sort of the the social working group over there, who was working with the nearby South Chicago people and trying to understand all of that. So it was a very good. That was also a very useful experience for me.
Fabulous. Tell us about now the crucial transition. It's kind of circling back.
Yes.
Okay.
Yeah.
And this is a transition which is not easy because all of us in some or the other way have done that. Tell us first and the foremost thing about why you decided to move back. That is a very important question. Given the kind of background you have, if you wanted, you could have probably stayed back. What is the reason you decided to come?
Yeah, I think for me, so when I left to go to the US, in a sense, I always knew that I wanted to come back and work in India. Whenever I started, working as a professor or a permanent job, I wanted to be in India. Mostly, I think at that point of my time, even before I went, my thinking was that I did. There are many challenges, but I did growing up in India. I understand India more, the people more, and I really wanted to work here, live my life here. I didn't want to completely detach myself from this. Of course, moving to the US, moving to the US at a later stage is different from moving when you're younger.
Absolutely.
So you have a lot more perspective when you move when you're older. So I enjoyed my time over there. I learned a lot of things. I also, understood that society better. But I think I always knew that I will come back. So that was easy for me in that sense. It was not a big leap that I was making belief-wise, right? But it helped that both me and my partner wanted to move back. So in that sense also it was easy. But and then another thing, by the time I was finishing my postdoc, and I also you start to understand that in India the cosmology community is growing, and it's a very good number, and there are people, because by the time you finish you realize that you need that environment also to talk, like scientifically also you need that environment to talk to people around you, and you enjoy aspects of your science which are important to you, right? So you need that collaboration all the time. So in India, the astrophysics community and the cosmology community is constantly growing. So now India is also part of a lot of international collaborations as well. And it's an exciting time to be back in India also.
Yeah, recently there is also an approval for a major telescope.
Yes, for SKA, and there's LIGO coming up, and also also now doing science collaboratively is much easier. So also there's a large optical survey coming up called the Urbana Observatory, and you want to be a part of that as well. And it's you take all that and you can come back and you can actually have a really nice lot of not a lot, at least a few of us did decide to come back and stay here. So it's a good time even scientifically to be back. And so now once you made that decision, so I did not apply there. So I thought, first let me try India, and then we'll see if what happens. So things worked out. So things worked out well. So it was lucky also in a way. And I came here at sort of, I also did not apply widely over here. I came here because also the ISA Pune department expressed an interest in growing the cosmology department over here. So it was also a very good opportunity to contribute and help me build my career around something that is new. So I was very excited to come back in that sense. And it's and also, like, I really I think the undergraduate, graduate, student experience in India is very nice. It's a very vibrant community. I really liked my college and my master's days in India, and I like that atmosphere a lot as well. So I wanted to come back to a place like this. So it was an easy decision in that sense. Of course, you're moving from a place with excesses of resource to a place which is largely resource starved. So there are going to be issues, of course, but I don't think the issues are very hard to navigate, and there's a lot of things you can do over here. And I don't know how much of my mentor there used to say that there's so much you can do over there, right? Because there's so many new things you can start, and so much place to do, have a footprint there. I don't know how much of it I will be able to do in the future, but at least it was a very exciting opportunity for me to come back. Yeah. Fabulous.
Very nice. Very nice. Briefly tell us about the questions you are now interested in, your group, and how big is your group?
So yes, now I have a group, and that's really nice. I get to work with a lot of students, and I think that's so valuable because
I should mention, by the way, to listeners that astrophysics is one of the sorted of topics in ISA Pune. Pune itself is a hub for.
Pune is a hub. I mean, I didn't realize this before. I knew it theoretically that Pune has a lot of astrophysics, but it has inspired so many people in cosmology and astrophysics. It's amazing. Yeah, it's a really nice place. I think they've done a great job. Yeah. So now my group, so I have 2 PhD students in my group, and I have 2 master's students and another master's student who graduated. And I have about 6 undergrads in my group, right, at this point of time. That is a completely new experience. I mean, I worked with students before, but as a professor, making that transition from a postdoc to a professor is quite a interesting and challenging. You have to figure a lot of things out. That's the thing about science. As soon as you think that, okay, now I'm getting used to this, I'm really understanding now how to be a PhD student, you become a postdoc. That's completely different. You suddenly start feeling comfortable with being a postdoc, and you become a professor, and that's completely different. Your previous thing is not really training you for those aspects. So, but I really enjoy it. I think working with students is very nice. You often, as you progress through your career, the time you get to spend on every small aspect that you diminishes with time because you have more responsibilities. So I think it's great to have students to keep that going, and also encourage you to keep doing that yourself. The reason you love science. So I think I have 2 students in my group now, 2 PhD students, one of who is working on understanding. So this is related to massive galaxy clusters, observations to make predictions for massive galaxy clusters. Essentially, the massive galaxy clusters are really large dark matter halos that have around masses of around 10 to the 14 times, 1,000 billion times the mass of the sun. And these are really large potential wells. And so he's working to understand the connection between how the gaseous component of the halo and the dark matter component of the halo interact, and what kind of observational signatures, or there are, how do we understand certain observational signatures that we are seeing by understanding this interconnection. And the other, so I'm generally interested in these questions of understanding the halo structure. I think the direction that I'm very excited about right now is to push to dwarf scales, which means that push to scales of smaller dark matter halos, smaller and smaller dark matter halos. So I've been working with massive clusters, which are really large halos. But with higher precision measurement and fantastic data coming up, you can really go to the smaller scales. And these smaller scales are really, really interesting because the smallest galaxies or the smallest halos are basically going to be dark matter dominated. So, a lot of the things that we've learned about dark matter is from studying the dwarfs of our own Milky Way, so the satellites of our own Milky Way galaxy. But now you can, go out and look at these smaller objects in a larger statistical sense. So I'm really excited about pushing in that direction. And other than that, I'm also interested in looking at sort of the interconnections between these transient sources of gravitational waves and galaxy formation and structure formation.
Yeah. There are so many interesting things. In fact, I would be also linking some of the very interesting talks Susmita has given. There's a very nice TED talk regarding dark matter halos. And also I found one talk at ICTS, which is slightly more technical, but somebody interested can look at it and learn more about interesting aspects. So this has been a wonderful overview of your research. And the other important aspect I keep emphasizing always is a scientist is not just only about the questions they ask at their desk or with their group or at their laboratory, but there is a lot more for a scientist to explore within the society. Absolutely. And the element which also is very interesting in your own life is that you mentioned that you are interested in art, and I also know that you are interested in gardening. I see that
I'm interested, but I can't say I'm very good at it.
Yeah, no, interest is more important. That's the first thing. But you're also, of course, kind of deeply involved in dance. Odissi is something which you are seriously learning, and you have a background too. Can you tell us a little bit about that? What is the background? How did you got interested, and what do you want to do, and things like that?
Yeah, so I think I have always been very interested in dancing. Maybe in my mind that would be have been an alternative career if I wasn't a scientist. So as a child, I used to learn Bharatanatyam. I did for a few years actually, but then mostly I actually did a wider range of dance in my school, in the sense of I did a lot of creative dance, and which is, by creative dance, I'm saying, which is not classical or folk. It's more abstract. So I participated in a lot of dance events growing up, in a lot of dance competitions, and used to participate in all of my school competitions. And I really enjoyed that, and I spent a lot of time in my school actually doing that. Also enjoy choreography a lot. So through school and college, I did a lot of dance. Another surprising place where my dancing interest took a huge boost was essentially IIT actually. Something that you don't expect about IIT. They have a very vibrant, IIT Bombay has a very vibrant extracurricular culture. And they used to have, all kinds of programs, of course, in many different things. And one of the things that they used to have was like this active hip hop club actually, and they used to get a professional from outside who used to teach. So I wasn't part of that, but I did a lot of Western dancing over there as well, and I really enjoyed. I spent a lot of time in IIT dancing and doing dance theaters and acting. So yeah, I encourage students to do that. I encourage everyone to have something. So it's really important to have that aspect in your life if you can.
See, that is an important aspect, isn't it, Susmita? Because it gives a person personality, right? Because it's not only about defining yourself only through some aspect of your occupation.
Yes.
There is an extension of the same person into other domains.
Absolutely.
And the other domain many a times feeds very positively to the subsequent kind of process what you do. And you probably would have found that.
Yes, absolutely. I mean, just it feeds a lot into what you do. Even something as simple as, of course, it enriches you as a person because you're devoting yourself to something. You're absolutely right. You're not defining yourself simply by your occupation, and it's really important to appreciate that and have a refuge somewhere also, right? So where you can cut off and you can appreciate something, you can value something else, and you can value another way of thinking also. Actually, it's very important. For example, now doing Odissi, or at this age, I'm probably old to do. It takes a lot of physical effort, I think, but that discipline is so important,
absolutely.
right? Like, it's amazing how much whether you learn some form of classical music or dance or something, that discipline is really feeds into your other aspects of your life, right? Yeah.
Folks, the word discipline is slightly old-fashioned, but the most important thing. In fact, that is something, it's so crucial.
Yes, absolutely.
No matter what skill you want to develop, either in sciences or any form of art. Yeah, it's not very fashionable to talk about that. It looks a little different, but as you correctly mentioned, that focus is very critical.
Very critical, yeah. So I think anything that you put your time into, your focus into, even reading, actually,
absolutely.
I enjoy it.
Yeah. That is something I would want to ask, because I know that you read a lot. You also are motivated by very interesting literature outside science. What is the kind of books you're interested in?
Strangely, I think one of the things that I love reading all kinds of books, so I think it's hard for me to pinpoint one thing, both fiction and non-fiction. Strangely, I find that as far as non-fiction is concerned, I find myself more drawn to, and I don't encourage it, so I'll still go ahead and say it. I find myself more drawn to reading sort of non-fiction in other subjects. Like I really love reading bio non-fiction or economics non-fiction or history, of course, rather than always physics non-fiction, right?
Absolutely.
Yeah.
In fact, that's a great way to learn something.
Yes. And I was just thinking about this the other day. It's like, why is it that I find it harder to read? Because I feel like I should be reading this, And, but I feel like it's because when I read physics, I feel the urge to, like, if I don't understand something, I feel like I need to work this out, right? Like, why am I not getting? Whereas I don't feel that amount of. I feel more easy to wander around in when I'm reading, as in not wander aimlessly.
It's a creative kind of exploration.
Yes,
so to
in reading maybe economics or bio non-fiction or something like that. And I of course love reading fiction as well.
Very nice.
I think another thing that I really, very important experience for me was, because I grew up part of my life outside of Bengal, I actually learned Hindi till class 12. One of the things that I taught myself to do later was to learn Bengali so that I could read. And this was because when I went to college, there were so many people from so many parts of the state, and how, excitedly they would speak about Bengali literature. Really influenced me. And one of my friends gifted me, I knew how to read it, like very rudimentary way, but he gave me a book and he said that, why don't you read it? Same person who was also made the math story, but anyway. And I think that has been one of the most important things for me.
Absolutely.
And I hope to read more. I read quite a bit of Bengali now, and I hope to read more, regional literature. I think that's in other languages.
Absolutely.
Hindi also now. I think I would like to go ahead and do it. Yeah.
Wonderful. This has been a very enlightening and very engaging conversation, Susmita. And I hope you will also find many interesting things in your research and outside research, a lot of endeavors, whatever you are now pursuing. So this is a part of an emergence series, which is some kind of a part of the Pratidhwani podcast, which means that I will request you to come back and have a conversation later on at some point of time in future. And this is something which hopefully also will become a seed for some very small seed for an oral history archive, which is one of the motivations behind it. And especially when it comes to physics, given the fact that I have background in physics, it's much easier to converse. But I would also want to do this with other people. So yeah, I thank you very much for the time you gave.
Thank you so much for having me.
Yeah.
It's a great experience.
It's been a wonderful conversation. So this is Pratidhwani, where we try to humanize science with Susmita and her wonderful research on halos, where she explores a lot of interesting halos of dark matter and
signatures of dark matter,
and also great to learn about all the other interests. Thank you very much.
Thank you so much.